In the 13th century, the Mongol Empire faced a logistical crisis that threatened its internal stability. The terminal lag of communication across the largest contiguous land empire in history. Geographic distance at this scale operates as a physical, thermodynamic barrier to central administration. Moving a message required pushing a physical body across extremely hostile terrain. If a directive from Karakorum took 6 months to reach an army in Persia, the strategic window for that order likely closed before the rider arrived. The intelligence was obsolete by the time it was read. The unbroken topography of the Asian steppe represents thousands of miles of high-friction geography. Superior military force loses its strategic value when a central command cannot react to shifting fronts. Without high-velocity data, an army in the field becomes an isolated unit, incapable of contributing to a broader imperial objective. To survive, the Mongol state had to engineer a physical mechanism to force information across this continent, faster than human beings had ever naturally moved. For the Mongol Empire, subduing physical territory was secondary. Their primary survival imperative was conquering the friction of distance itself. Genghis Khan recognized that maintaining expanding borders required a departure from traditional logistical engineering. Pre-industrial communication hit a hard ceiling at the biological limit of a single horse and rider over long distances. This graph maps the speed of a standard courier. Velocity collapses after the 3rd day as physical exhaustion sets in, severely limiting the range of any centralized order. Traditional agrarian empires accepted this boundary as a fixed law of nature. The Mongol objective was to decouple the informational payload from the physical carrier, creating a system where the data never slowed down, even as the riders did. The resulting system, the Yam, functioned as a militarized intelligence grid. It relied on state-enforced compliance to prioritize the movement of military directives and surveillance. While contemporary European models relied on inefficient, tangled civilian networks, the Mongols utilized a direct, node-to-node military vector designed for maximum speed. The Yam operated as a mechanized weapon, securing absolute data supremacy over conquered populations. The hardware node of this network was the Örtöö. These stations were constructed at exact 20 to 30-mile intervals, maintained regardless of terrain or biome. This matched a horse's maximum sprint capacity, ensuring a fresh mount was available precisely when the current one reached biological exhaustion. Each Örtöö contained a military garrison, specialized remounts, and emergency rations, all maintained for the sole purpose of supporting the vector. To minimize latency, riders signaled their approach from miles away. The station staff would have a fresh horse saddled and ready before the courier even arrived. By leaping directly from an exhausted horse to a fully fresh one, the courier maintained constant forward momentum. This engineering philosophy treated the horses as disposable biological batteries, sacrificing the animal to preserve the velocity of the information. Thousands of these heavily guarded nodes eventually blanketed the Eurasian continent. These stations stood as permanent markers of Mongol authority in otherwise empty landscapes. The Örtöö network overlaid a predictable mathematical grid onto the geography, allowing the central state to measure and traverse the continent with mechanical precision. While the stations were static, the system's effectiveness relied on the human rider acting as the biological vector. Sustaining consecutive high-speed sprints across multiple days causes extreme physical trauma. Couriers utilize tight torso banditing to provide the necessary internal support to prevent organ rupture during continuous high-impact riding. Bells and horns were standard equipment used to alert the next station, preventing any pause in data flow. Historical illustrations show a highly specialized riding posture and a lack of heavy gear, both optimized for sustained speed over long distances. This physical endurance resulted in an unbroken data transfer rate exceeding 200 miles per day. This chart shows the disparity between contemporary courier systems. While European and Song dynasty networks moved at a sluggish pace, the Mongol Yam achieved a consistent 200 miles per day. The Mongols converted raw biological suffering into unparalleled strategic speed. Maintaining a supply chain across thousands of miles of conquered territory required total local compliance. The administrative solution was the Paiza. This metallic token carried the inscribed authority required to bypass local laws and resource scarcity. This is a metallic Paiza. It was a physical artifact of the Khan's power, forged to be immediately recognizable. The vertical script engraved on the metal provided proof of the bearer's status within the imperial hierarchy. Possessing this token allowed a rider to commandeer horses, food, and labor from any local population without payment. Holding the Paiza granted a courier the legal standing of Khan himself. It empowered the bearer to overwrite local governance, turning a solitary rider into a sovereign authority. This absolute authority eliminated the bureaucratic friction and economic resistance that typically slow down long-distance communication. The Paiza functioned as a physical algorithm, forcing total compliance from a fractured continent to keep the network running. Under Örtöö Khan, the Yam enabled macroscopic strategic coordination that was previously impossible. Örtöö Khan institutionalized the Yam, expanding the network into a permanent apparatus of the state. He built Karakoram as a centralized data processing hub. All network intelligence across the empire eventually converged here. High-velocity intelligence allowed the central command to direct multiple armies across different continents simultaneously. This led to the era of asynchronous warfare, where Mongol invasions into Eastern Europe, China, and the Middle East were coordinated from a single center. This map shows the result: synchronized data pulses traveling outward from Karakoram to trigger military strikes on 3 separate fronts with perfect timing. The Mongol state successfully engineered absolute data supremacy. By solving the problem of distance, they achieved the ability to coordinate a continent-spanning empire from a single stationary center.